My name's Nick. Brief bit of background. My background actually is AI, doing that for about 30 years. On the security side, I think the thing of relevance is I used to be CTO of OMTP. So OMTP was the standards body responsible for defining the trusted execution environment. So in doing that activity, it's given me a relatively deep insight into the technology and what it takes to get that technology deployed at scale, but also quite a lot of insight into the commerce and the politics around it. I mention that because when I go through some of the security systems, because of my background, I tend to see it through both lenses at the same time. So, firstly, the IoT security endpoint problem. So to some extent, the horse is bolted. There are devices already out there at scale compromised. And I'll try to do a little bit of modeling just to sort of like back up my assumptions in this area. Just knocked it up on an Excel spreadsheet. Happy to share it to see if other people want to agree with my assumptions. But if you just take some numbers about general market growth, take some assumptions of how many are good, how many are bad, how many are moderate, overlay a churn rate, it produces a picture where any way you cut it, no matter how well you sort of the IOTSF does or the guidelines do in terms of protecting new devices, there's still going to be a load of bad devices out there on the market doing damage. And the question is how do you deal with that? So the other reason the IoT endpoint, security endpoint problem is broken, is it's just really, really difficult. I think 2 years ago I did a presentation where I go through one by one for each of the technical challenges. I won't do it again now, but essentially there's a lot of very, very complex technical challenges that if you want to be able to address that problem at scale. But the gateway is interesting. The gateway is interesting for two reasons. One, it naturally centralizes all of the activity, especially when it's happening in a domestic environment. In theory, it sees all the incoming connections, all the outgoing connections. Probably more interesting is all the internal connections of IoT devices talking to each other. In theory, because it's an intercept point, you could use it as a place to implement permission requests. And as we'll talk about a little bit later, I think there's some options for using the gateway to do both configuration and updates. That's one side of it. The other side of it is the more negative, which is unless the hub is protected, it really becomes a major attack vector in its own right. And actually, John Moore sent me this yesterday, actually. If you don't believe me, this is a semantic report out. 75%, according to their report, of IoT devices which are compromised are routers. So the question is, what are you going to do about it? So before I go into detail, there's a few sort of reality checks. So firstly, so the IOT has already done some sort of like white papers on hubs. I think that's good progress. The reality is the language needed to describe what's really happening in the home network isn't really, in my opinion, mature enough. It's quite complicated. And actually, when you go down and look at each individual device and seeing what its function is, simple things like your DNS function in your DHCP, they can be repeated multiple times on most people's internal network, depending upon how they set it up. The Alexa hubs, they're actually two different things, depending on whether you buy a plus or not a plus. A normal Alexa hub is just a voice interface. You buy the plus, and you've got an IoT proxy gateway as well. And I think we need better language to be able to describe what the roles are of all the different elements that sit behind the internal network if we were going to have any chance of protecting these assets effectively. Second thing is just a bit of a reality check. I get the impression, I'm sure this isn't a criticism of anyone in this audience, some people approach the IoT security problem in a totally academic way, and they don't actually sit down and order crap devices off the internet. Here is an array of devices. These are just light bulbs. The simplest IoT device, a single bit actuator, a single bit sensor. So you've got the Wi-Fi routers over here. They are classic IoT, but then you've got Z-Wave, you've got Zigbee, you've got Bluetooth. A lot of people just don't care, don't know what they're buying. Those are four completely different protocols, and actually, those ones, there's no I. There is no internet. These are protocols that work at the sub-IP level. And I think, and I'll come back to this again in this presentation, we always need to anchor back the problems in terms of the real devices that are being bought. So why a smarter, more secure hub? So, can anyone see what's wrong with that picture? Router admin page. There's no certificate on it. So this isn't unusual. Go home tonight, go into your router, go to the management interface and have a look. It is unencrypted traffic. I mean, you can buy a little one of these dongles, a bit of Wireshark, and literally I can sniff any password going to the router. It makes a mockery of a lot of the stuff people are looking at. Why are we bothering defining the fact people don't use default usernames and passwords when if I've compromised the router, I can see everything? And the thing is, this doesn't just hit the router. Any webcam with a HTTP interface, similarly, doesn't have a certificate on it. So all of that traffic is clear. You just need one thing on the inside of the network and everything's in the clear. So that's the first problem that needs a solution to. And so what I'm going to do in these slides is just throw out there some of the big challenges and just talk about very briefly what the potential solution is. And in a lot of the cases, the solution lies in coming up with some collaborative technology we can deploy at scale that solves that problem. And in this instance, it's really simple. You need a way of logging in that route into that router and managing it without having your credentials compromised. And in fact, just as an instance, Alexa does solve this problem, but Alexa solves it in a different way, because what Alexa does is it gives you an app, and in that app is a root certificate which then can negotiate securely. But unless we address this problem sort of at scale for the mass market devices that aren't owned by one or two of the three silos, I mean, there's just a major issue there that has no solution. Second problem, again, it's quite basic. I'm at home. There's lots and lots of devices on my network. I want to know that something's happened. So how do I get an asynchronous notification from the router to me at home? Even if it's as simple as, the light's been turned off or something's been opened. But actually, from a security perspective, I want to know when updates are available. So how's that going to happen? So unless that problem is solved, you've got a major usability issue. Because you can't just expect everyone to log back into an admin interface and hope that they're notified. So that method of doing secure connections needs some sort of like symmetric asynchronous messaging protocol back to applications on the local network. And then this is really just an extension of the first point. So the problem that the user cannot make a secure connection to another device on the network actually extends to almost every single one of the devices sitting on that internal network. They need a method of negotiating the encryption credentials. Right, root of trust problem. So whether it's root of trust, software integrity, secure boot, verified boot, etc. So who here in the audience feels as though they would be able to go and implement secure boot on an IoT device, end to end? Okay, maybe got 1, 2, 3, 3.5. Okay. I'm skeptical already, but even so, only having 4 hands up in this audience should be a concern. For the simple reason, the IOTSF recommendations, the DCMS guidelines, and these all claim that this is a requirement. I can tell you, because we've actually been trying to do it for a long time, it's really, really hard, technically. But moreover, commercially, it's almost impossible. I mean, if you actually want to implement secure boot, you've got to negotiate with silicon vendors. That is very difficult to do if you're a small or medium-sized developer. So we've got this big issue here that I don't think is properly being addressed, which is, if on the one hand, we are saying that all devices must have this capability, but on the other hand, we don't have many people that know how to do it, and there isn't the commercial infrastructure to negotiate it, we're just creating a paradox. So I know this is one of the things that I feel very strongly about, and I've been advocating in sort of like various different areas, but I think we need to lower the barrier of entry, both in terms of better education, understanding how to do it, but moreover, there needs to be commercial intermediaries that mean, so I've been to Taiwan, I've gone to MediaTek, I've tried to do this, they said just go back when you've got an order for 20 million units. I can't do that. So we need something to streamline that process. So let's look at these ones. These are our Zigbee devices. 1, 2, 3, 4 Zigbee devices there, all light bulbs. As a user, I don't care, I've just bought them off Amazon, and Zigbee works on the router. Fantastic, great. And everybody says, right, I need to update these devices. So how am I going to do that? I need a different updater app for every single one of these devices. Each manufacturer, there is nothing standardizing that method. And that's just within the narrow set of just the Zigbee light bulbs. It's exactly the same for the Wi-Fi ones. So, you know, we're promoting an environment where we're asking users to up their devices. I'm in my house, I might have 50 light bulbs. They come from a random number of manufacturers. So how many update agents do I need to install at home? That's problem one. Problem two is I'm a bit worried about this default password problem. You know, we're actively promoting the fact that we should have, you know, different passwords for every single device. So if I've got 50 bulbs at home, have I got to remember the username and password for every one of those devices if I want to update it? So there's really some fundamental issues that need to be addressed in terms of not the how do you update. I've been doing telecom stuff to know that firmware updates is a really hard problem and there's lots of different solutions and we have to embrace that. But from a user's perspective, I think I deserve to have one interface where I am told all of the updates that are available on that network, no matter how it's implemented. And I think that can be done quite simply, but it just needs a level of industry alignment on what those mechanisms and protocols need to be. Network isolation. So this is one of the things I think a couple of the other speakers have talked about. It's also in there as a requirement in the hub specifications. It makes a lot of sense. It's good security practice to contain, stop the bad devices getting out, but also stopping, you know, the devices attacking each other. And it makes sense to me. You know, I have a lighting isolated network. And have a speaker network. There's no real reason why they need to talk to each other. So why can't we come up with a mechanism via which we can define totally isolable networks to mitigate the risks both inbound and outbound? And I think you find if you do this at a detailed protocol level, it then actually opens the door to a lot of other sort of like mitigating activities that we'll come on to in a minute. Next one. Application interoperability, not strictly speaking security, but I just think this is common sense. So I've got this crazy dream that I can have one application on my phone and it'll be able to turn all of those light bulbs on and turn them off again. But you'd be amazed how difficult that really is. So let's just take just Zigbee. So forget all of that, there's just Zigbee. We've got two Zigbee with Exabridge and just a random other one you can buy off Amazon. So you've got interoperability between here and here. But if I want to create an application, there is no interoperability between here and here. I have a completely different app I need, like the Alexa app to control my apps over here, and a totally different application if I'm using a different sort of like different hub. Now, from my perspective, if this isn't solved, then all that's going to happen is you'll have Google Home and you'll have Alexa and a couple of others, and that will be it. It will just be the standard 3 ecosystems and just forget everything else. I actually think this layer of interoperability is actually more important than this one. And it's important because I want to be able to exert control over my apps and the ecosystem northbound of that. But there's another knock-on effect which is more important and much more security pertinent is, I think I deserve the right to be able to control what external applications have access to my devices when. And you can't achieve this ambition without actually then first solving the interoperability problem. Because if you solve the app interoperability problem, you then have essentially a common policy enforcement point here. And I think this is it's a very sort of like forward-looking requirement, because I don't think we can do it anytime soon. But from my perspective, this is one of the most important things that we should be looking at if we are genuine about want to be creating secure IoT ecosystems. And this is the final one, I think, where it all comes together. And this is where sort of like draw in on sort of on the AI analytical piece. There's a lot of stuff that we can do to secure IoT devices by, doing network segmentation, sort of like creating clever rules, having better device identity. But the reality is a bit like sort of like firewalls. A lot of the real mitigation is post the event. Something will happen, and then you want to be able to address it. And yes, you can use smart analytics to do all that type of stuff, but anyone that knows anything about sort of like AI and analytics will know the fundamental thing that you need is data. And the data that's relevant here is, the problem is shared by everybody. Everybody's suffering the same problem. So there must be some motivation and incentive to actually share the data that helps you determine, essentially, what is the fingerprint on a badly behaving webcam. And I think, if we manage to achieve that, it opens up the door to much more sophisticated methods of actually managing IoT security. It is a simple fact. Most users will not interact with the security modules that are implemented in the router. And therefore, if you can create this ecosystem where you've got a lot of crazy stuff going on down here, different protocol bridges, different voice gateways, different Wi-Fi, home plugs, voice routers, and they sort of like gather together the salient data, so what I call the fingerprint data of the activity. And then this can be shared with trusted entities, what I just call cloud-based security services. I won't say who they are, but they're obviously people who are already in this space, and there are people that want to be in this space. Then that starts to open up the ability to then create this closed loop where you can dynamically lock down your system. So what I want is I want to go to Amazon, I want to buy any of these units that I want to go and plug them all in and sort of like not worry about it. And this type of ecosystem will enable this to happen, because what will happen is a suspicious thing will happen. That will get escalated, that can get flagged, you can then correlate that with the salient activity beforehand, and then that can be used to then sort of like reprogram the sort of like the dynamic rules that are in place on the network itself. So it's essentially a very advanced firewall, but working on the internal network for both the IP and the non-IP data, but using sort of like shared information to drive it all. So in terms of what I've talked about today, I've just focused on the problems. There's more than one solutions to those. We've recently, as John mentioned earlier, we've just been awarded a project, and it's a collaboration with ourselves, Cisco, IoT Security Foundation, and University of Oxford, where we will be sort of like actively looking at each of these issues that we're talking about and presenting concrete sort of like methods and technologies. The idea of that is that would become the basis for sort of like collaborative activity going forward. So just to sort of sum up, so my humble opinion, I think common sense, the IoT endpoint security is not going to be solved anytime soon. The IoT hub itself is a risk in its own right. Remember, your Wi-Fi's are in the clear. 75% of all devices, IoT devices, are compromised routers. But it's not just a risk, it's also an opportunity. There is technology we can add to the router that will fundamentally mitigate a lot of the risks that we talked about. These very specific problems, I mean, it gives us an opportunity to really do something sort of like concretely at the technical level, rather than just sort of like a few sort of like guidelines and recommendations. But collaboration is absolutely key with this. If you don't have collaboration, we just revert back to the sort of like Alexa, Google sort of like three silo ecosystem. And if that happens, to be honest, a lot of the work happening in organisations like it becomes almost irrelevant, because the commercial ecosystems will solve them. And that said, I've just focused on the problems, because it's hard enough in 20 minutes just to get the problems across. If you're really interested, we've got a stand outside where we've got some end-to-end demos that actually implements the concrete technology which addresses each of the issues that I talked about. Thank you very much.